Hi, let's keep completing the square, but this time with a constant term. Things are going to get a little trickier, but we'll figure it out. Let's go. In this case, we have an algebraic expression like x squared plus 6x plus, let's say, 15 in our case. Okay. So as always, I'm doing my visualization, right? I know how to complete a square. Well, this x square means a square with a side length x, and I will add something to it, and then it will become a larger square. I know the story, okay? I know this where this 6x is going to come from, right? So let's call this side length x and this side length x, and now this 6x comes from this rectangle on the right and rectangle at the top. So it's shared by two rectangles with areas 3x. Because when I divide 6x by 2, now it's 3x. And the area of this square is x squared, okay? And so in order to complete the square, I can find the area of this small square. Let's find it out. Well, since this side length is x and okay, I can find this by dividing the area by the longer side and find the shorter side, which is 3. Okay, let's show it here. These cancel each other, and then I have 3. So one side length of this square is 3, so it makes its area 9. Oh, it's not 15. So I think to myself, only if I had s squared plus 6x plus 9, okay, this would be a perfect square. It would be square of the sum of x and 3, right? 3 here. And it would be the square of sum of x and 3. But it has 15. So how should I put it? Okay, as you can see, this expression is 6 more than this expression. So I can write this expression like x squared plus 6x plus 15 equals to. Now I can write this expression, which is x plus 3 squared. And then I know that I will get a 9 in the end, and I will add 6 more, right? There you go. So I have my square here. Here is the area of the square, and here is my excess, right? I put the excess here, and so I can see it in terms of a perfect square now. Okay, let's do one more example, but this time with negative coefficient. X squared minus, let's say, 2x plus 4. Let's do this. Let's complete this to a square. Okay. Let's start with x squared. Okay, that's my x squared. Since I'm going to subtract something, I'm going to make a smaller square, right? And I know where this 2x will come from. It will come from these rectangles. You can check our previous videos if anything seems new to you for a perfect beginning. Okay, x squared, here's my x squared. So side length of this square is x. Here are my x's. And I subtract 2x. Well, I know very well that this 2x, 1x comes from this side, and 1x comes from this side, right? Okay, so since this side length is x, this side length has to be 1, and this has to be 1. In order to make it x, x comes from here, x comes from here. So I subtract them, these two x's. Great. So I will arrive at this square. But since this side length is 1, I have to put one of these squares back. Do you remember? Okay. And then what I will find is this part is x minus 1, and the area of this part is x minus 1 squared. Okay, almost there. Let's do it from the beginning. I have my x squared. Now I subtract my x's, which is 2x. Great. I subtracted this part twice, so I add it back and I arrive at x minus 1 squared. Well, this part is okay. We've been doing this for a while. But I know that this is a perfect square, but this one doesn't seem like a perfect square because it has 3 more than that. So what I can do is I can write this as a square, right? And then I know that I have to add 3 to this expression in order to get this one, and then I add 3. So I can write this expression in terms of a perfect square. Now it's time to figure out what's going on here. There's a pattern going on, and I must be aware of it. You see where this 3 comes from? Well, it's the half of this number, because half of this number is the shorter length of this rectangle, and then it goes to the area of the smaller square. Okay? And here again, the sum of the rectangles is 2x, so area of one rectangle will make 1x. You can see it clearly here. Right. Let's make one more example. So you are clear about taking half of this, and then we take half of this. This makes 1, so we can see this 1 here. One more example. Now let's get a little bit trickier, okay? X squared minus, let's say plus 5x, I don't know, minus 1. Let's see what's going to happen. Okay, I want to write this in terms of a perfect square. Let's do it. I'll start with x squared. And then I add 5x. Well, I will visualize this as a larger square, since I will add something. And I know very well that half of this 5x will come from rectangle on the right, and half of it will come from the rectangle at the top. Okay. 5x over 2 will come from here, and 5x over 2 will come from here. So these parts, we call them x, and since this side length is also x, this side length has to be 5 over 2, because it will carry the half of this area. Okay, so it makes the side length of the smaller square 5 over 2, and the area becomes, it's square, right? 25 over 4. So if I only had this equation, x plus 5 over 2 squared equals x squared. Here's your x squared. And then this 5x comes. And then if I only had 25 over 4, which I don't have, I have minus 1 instead. So what's going to happen now? How am I going to arrive at that minus 1? Okay. Well, let's start writing this expression in terms of this one. X plus 5 over 2 squared equals, no, not equals. Okay. So this one equals to x squared plus 5x plus 25 over 4. So what should I do? I have to subtract something. Okay. So these are going to be equal. So I will subtract something from 25 over 4, right? I'm subtracting something, and then it will become minus 1, right? So the equation is corrected. Okay, let's find that number. As you can see, let's call it A, okay? And then I bring it here, and I bring it to this side of the equation, and then it becomes 29 over 4 equals A. Let me show that to you. 25 over 4 plus 1 equals, I do this operation and then find 29 over 4. So, great. Now, since this is 25 over 4, if I subtract, if I subtract this 29 over 4, then I will have my equation. Okay, this one's a little bit tricky. So it's better if you make one more example about this one. Let's go. This one was with plus. Let's do it with a negative coefficient. X squared minus 7x plus, let's say plus maybe minus, yeah? Minus going to be better. Let's say minus 5. Okay. So we'll write this in terms of a perfect square. Let's start with our square. This is our x squared, obviously, because we'll get smaller, we'll get shrink, we'll not complete a square, we'll diminish a square. There you go, you subtract something. Okay, there is x. And I subtract, okay, this subtraction, the area 7x comes from two rectangles. Now, half comes from here, I know that, and half comes from here, right? So, since this side length is x, this small side length has to be 7 over 2, right? Because 7x over 2, the area of one rectangle, plus the area of the other rectangle will make 14x over 2. When simplified, it equals to 7x. Here you can see it. So we'll subtract it and then add this part in order to make the equation right, which is square of 7 over 2, which is 49 over 4. So if I add this, and then I will have my perfect square. Well, let's do it. This part is 7 over 2, and this part is x minus 7 over 2, and this part is the area of a small square and equals to this algebraic expression. So let's write it. X minus 7 over 2 squared equals x squared, the whole square, minus, well, 1 comes from here, 1 comes from here, and then I know very well that they will make 7x. And then, since I subtracted this part twice, I add 1 back, which is 49 over 4. So now I have my perfect square. But wait, instead of this, you have this. So I have to turn this rational number into this. Let's do it. I want to turn 49 over 4 to, let's call this A. I will add something to it, and then it will become minus 5. Okay, minus 5 here. No, not that. We will send 49 over 4 to this part of the equation. A equals, well, let's calculate it, minus 69 over 4. You can do the rational operation on your own. Okay, it's a simple operation. And we find A. So, in order to make this, in order to turn this into minus 5, I have to add this number. Okay, let's do it now. I will erase this upper part and then write it here. Let's go. We can do this. X minus 7 over 2 squared plus, since I have 49 over 4 here, and since I want to get minus 5, I have to add this number to it, so I add it. So rather than plus, I can put a minus here, right? Let's put a minus here, and now it's 69 over 4, and now I have my expression. These expressions are equal to each other. It's an identity. We wrote these algebraic expressions in terms of square of something, because it will help us greatly in understanding quadratics and quadratic formula. Okay, see you in the next video.